Hey guys, welcome to this week's one and only video lecture. Because of the Thanksgiving break, I'm only giving one video lecture and one assignment for you guys to do. So you're welcome. Today we're going to be talking about the electromagnetic spectrum. The reason why we're talking about this is because when we get back from Thanksgiving break, we're going to be talking about how electromagnetic radiation and the atmosphere interact. So I want you guys to have, some baseline knowledge of electromagnetic radiation before we start talking about it in class. So with that said, let's get started with this video lecture. All right, so before we talk about the different types of electromagnetic radiation, we need to talk about waves. So light travels in waves similar to waves in the ocean, and light is just electromagnetic radiation. So when we think of light, we think of visible light, but that's just one tiny sliver of the electromagnetic spectrum. There are also other different types of light that have high and low energy. Low energy forms of light are radio waves, microwaves, infrared radiation, which we've talked about a little bit this year. The more high powered forms of light are ultraviolet, X rays, and gamma rays. And all waves of light, and waves that we see, in the ocean, can be described in terms of four characteristics. They can be described in terms of their amplitude, their wavelength, their frequency, and their speed. All right, so let's talk a little bit more about those characteristics of waves of light. So the first characteristic we have is amplitude. Amplitude is just the height of the wave measured from its origin to its peak or its crest. So I'm going to draw a little bit here. If we were talking about this wave of light right here, its origin would be right here. Its peak or crest would be right here. So this length right there would be its amplitude. And the amplitude is just how bright or intense the light is. Another characteristic is wavelength. Wavelength is the distance between two successive crests. And the light or electromagnetic radiation we see has wavelengths ranging from 400 to 700 nanometers. And a nanometer is 1/1000th of a meter. So the wavelengths of the light we see are very, very, very small. And if we return to our wave of light up here, the wavelength would be the distance between peaks. So amplitude would be the distance between the origin point and the crest. The wavelength is the distance between peaks. The next characteristic we have is frequency. The frequency just tells you how fast the waves move up and down, or how fast they take to complete a cycle. If you think of the word frequency like we use it, it's how often something happens. So how often a cycle happens. All right, so if we go back up here and revisit our waves of light up here, these are actually radio waves. You can see the top wave is a high frequency radio wave. You can see it's completing many cycles in a span of time. Below you have another a low frequency radio wave. It's cycling much less in the same amount of time. So we call the one that cycles more high frequency. We call the one that cycles less low frequency. All right, last but not least, we have our last characteristic of light, and that is speed. Light moves through space at a constant speed. We call this speed the speed of light. And the speed of light is 3 times 10 to the 8th meters per second, so very, very fast. And because light moves at a constant speed, there is a relationship between wavelength and frequency. So that means if there is a shorter wavelength, that light is going to have a greater frequency. And if the light has a longer wavelength, there's going to be a lower frequency. So we can see that displayed up here. We have a shorter wavelength and we have a higher frequency, whereas up here or below we have a longer wavelength and a lower frequency. All right, last but not least, let's talk about the electromagnetic spectrum. So, the electromagnetic spectrum is just all the different types of electromagnetic radiation. And the reason that we're going to talk about this is because certain forms of that radiation interacts with our atmosphere. The visible spectrum of electromagnetic radiation, the types of light we see, is makes up a very small portion of the electromagnetic spectrum. If you look down here, this is the whole spectrum. This little sliver right here is the light we see. All the other forms of light on that spectrum, our eyes cannot pick up either because it's too high powered or it's too low powered, and our eyes just aren't able to pick that form of light up. All right, so let's talk about the different types of electromagnetic radiation. The first type is radio waves. Radio waves have the longest wavelength, and some examples of some things that use radio waves are radios, which we use to listen to music, television, and our cell phones use radio waves so we can communicate with each other. Microwaves are still very long wavelengths, but they're shorter than radio waves, and we use microwaves, in microwaves to heat our food. After that, we have infrared radiation. Once again, infrared is shorter than microwaves, and we feel infrared radiation as heat. All right, the next form of light we have is visible light. So the longer wavelengths of visible light are going to be colors like red, and the shorter wavelengths of visible light are going to be colors like violet and purple. The next form of light we have on the electromagnetic spectrum is UV, ultraviolet rays. These are emitted by the sun, and our ozone layer blocks certain types of UV radiation from reaching the Earth. After that, we have X-rays. X-rays have very short wavelengths. We're getting towards the end of the spectrum, the more powerful forms of electromagnetic radiation. And the practical use of X-rays in our life. Doctors use X-rays to take images of our bones and the sides of our body to make medical diagnosis. And finally, the most powerful form of electromagnetic radiation, the one with the shortest wavelengths, is gamma rays. Gamma rays are emitted by radioactive materials. They're also produced by the sun, and certain layers of our atmosphere filter out gamma rays, and that's a good thing because gamma rays are not good for our bodies. All right, that concludes this video lecture. It was a short one. Like I said, this is going to be the only one this week. You guys are going to have another video to watch that is going to be an ed puzzle, and then you guys will have a short quiz on the electromagnetic spectrum, and that's going to be it for this week. So as always, if you have any questions, please feel free to reach out. Other than that, enjoy your little break. Enjoy your Thanksgivings, and I'll see you after the break.